Examples 4 and 5 and the preceding examples could be thought of the chain rule with a single link in the chain. Examples 6 and 7, we've got the chain rule with maybe a couple links in the chain. When you studied composition of functions, you know that, well, let's see how to do this. I'm trying to think of what would be f composed with g composed with h of x is equal to f of g of h of x. So there's something kind of like that going on with these next two examples. And we just need to figure out what is the outermost function, and start by taking the derivative of that. And as we multiply by the derivative of what's inside the parentheses, the expression that's inside the parentheses will also be written as the composition of multiple expressions. So let's see, if I'm going to evaluate this, if I'm working from the inside out, the first thing I would do is evaluate this polynomial, x squared plus 5x plus 3. That's the innermost function, x squared plus 5x plus 3. After that, so that's, I guess, the h of x. H of x equals x squared plus 5x plus 3. And then the g of x, the next thing I would do is take that and do what with it? Cube it. So I would say g of x equals x cubed. That's the next to the innermost function. That's the one in the middle. And then after I cube that, one more thing left to do. Take the sign. So this function could be thought of as the composition of these three functions in that order, from inside to out. Now the outermost function is the sign. That's the last thing you do if you're going to evaluate this function. Take the sign. So when I look at this, I should think, okay, I want to take the derivative of the sine of something. Well, the derivative of the sine of something is what? The cosine of that something. So all the something there, the cosine of that something, all of that, times the derivative of that something. So the derivative of the sine of that expression is equal to the cosine of that expression times the derivative of that expression. So we write that down. Don't have to do much more with cosine. Maybe write cosine cubed instead of, well, let's see, no, I'm not cubing the cosine. I'm cubing the expression inside, so check that. Copy and paste that down below. Cosine of x squared plus 5x plus 3, that quantity cubed. Now, it's the derivative of something cubed. So we use power rule, bring that 3 out in front. The derivative of something cubed is 3 times that something raised to the second power, reducing the exponent by 1, times the derivative of that something. So 3 times that something to the second power times the derivative of that something. And then we're almost there. Just one more easy derivative to take. Chain rule has been pretty much exhausted there. And we just need to use the power and sum and difference rules from that point on. So it's going to be, how to clean this up, the 3 times the expression to the second power, probably should go in front. Then the cosine. Well, it's going to be a little bit more to it, I guess, when I take that derivative. Let me just not do too much there. More copying and pasting. The cosine of x squared plus 5x plus 3 quantity cubed times 3 times x squared plus 5x plus 3 quantity squared times 2x plus 5, derivative of that polynomial, 2x plus 5. And now, not a lot of rearranging to do. The 3 should go in front, and then those two polynomials, either the 2x plus 5 or the x squared plus 5x plus 3 quantity squared, should come next. and then the cosine probably last. Not a huge deal. If you left your final answer like this, I would not count off for it. So 3. You think it would look nicer with the 2x plus 5 next or the x squared plus 5x plus 3 quantity squared next? Anyone have a preference there? No preference? Okay. I'm going to go with the 2x plus 5 next. For some reason, that just feels right. X squared plus 5x plus 3 quantity squared cosine of x squared plus 5x plus 3 quantity cubed. There. So chain rule with an extra link in the chain, basically, is what's going on there. And I give that example and contrast it with this next one, because it's the same 3 functions, except the innermost function here, the innermost function is, well, the same, huh? H of x. Is it the same? The first thing I would do is evaluate x squared plus 5x plus 3. I think it is. And then the other 2 functions reverse roles. The next thing I would do is what? Take the sine. Yeah, so sine x is next. And then the last thing to do after you take the sine, cube it. So the sine function and the cube function, I suppose I could have permuted them in a more interesting way, those 3 functions there, but that's okay. I swapped the last 2.
So how do we know that sine of x comes before the x cubed?
Oh, great question. Let's see. Just imagine plugging in a number. Maybe you're trying to evaluate at x equals 0. Let's just keep it simple. You plug in 0 for x, and the first thing you do is say 0 squared plus 5 times 0 plus 3, and you get 3. And then you're thinking, okay, what do I do with that 3? So it's sine, basically sine cubed of 3 in that case. So you would ask yourself, would you take that 3 and cube it and then take the sine? Or would you take the 3 and take the sine and then cube that? It's 3 radians, basically. Or I guess it could be 3 radians. Since this means the same thing as the sine of 3 quantity cubed, the next thing you do with that 3 is take the sine. So sine is the middle function. The very last thing that you do in this case is cube it. That's the last thing to do. So the outermost function is the cubing function. It would help to see that if I would rewrite this as ddx of the sine of x squared plus 5x plus 3. One more set of parentheses. Squared. I hesitate to put the squared without an extra set of parentheses because then we'll wonder, x squared plus 5x plus 3, are we squaring that and then taking the sine, or is it cubed? Oh, thank you. Yep. That should be a cube. Thank you. So are we cubing that and then taking the sine, or are we taking the sine and then cubing this? With the parentheses placed like they are, we're taking the sine first. Taking the sine first, and then finally we're cubing it. I guess taking the sine after we evaluate that expression, of course. So, clean up some of the mess. So when I look at this and I get ready to begin, derivative of the outermost function is the cubing function. So the derivative of something cubed is 3 times that something raised to the second power times the derivative of that something. So 3 times that something raised to the second power, just applying the power rule to that. Taking the 3 out in front, reducing the exponent to 2, and then knowing not to leave it like that because the chain rule says I've got to multiply by the derivative of what's inside the parentheses, and so I'm going to multiply by the derivative of the sine of x squared plus 5x plus 3. So now, derivative of the sine of something. What did we say last time? Last example. Derivative of the sine of something is the cosine of that something. And according to the chain rule, times the derivative of that something. So copy the 3 times sine. At this point, I actually can get by with calling this sine squared. The notation is appropriate there because we're actually squaring the sine of that expression. So 3 times sine squared of x squared plus 5x plus 3. Now I'll take the derivative. Derivative of the sine of that expression is the cosine of that expression. Cosine of x squared plus 5x plus 3 times the derivative of x squared plus 5x plus 3. You know what the most common mistake is I see on tests with the chain rule? Students know they've got to use cosine, and they know it's got to involve the derivative, 2x plus 5? So what do I see? I see the cosine of 2x plus 5. And it makes me so sad to see that, because it's just you're thinking the right things, you know, it all has to happen, but it doesn't happen. You don't compose the cosine with the derivative. It's the cosine of the original expression, and then you multiply by the derivative of the original expression separately. So they just kind of get jumbled together. But if you do, a couple pages of these, then it'll be clear in your mind what to do there. I don't know if I've given you a couple pages of them. Maybe I've just given you a half a page of them. So I should probably give you more. 3 sine squared of x squared plus 5x plus 3. Cosine of x squared plus 5x plus 3. And then times 2x plus 5. Maybe read it like that. Is it maybe a little bit ambiguous? Maybe grab the 2x plus 5 and bring it out in front. That's the only thing I might suggest. Otherwise, you could leave it like that. So 3 times 2x plus 5 times sine squared of x squared plus 5x plus 3 times cosine of x squared plus 5x plus 3. And that's got to be enough, huh? Chain rule is designed, like all these rules, product rule, quotient rule, to make our lives easier. Does your life feel easier now than it was when you came in here today?